Hey guys, so today we're going to talk a little bit about using your meter and what continuity is. Okay, we're going to do continuity only today. So we're hoping to help you guys get more familiar with using your meter to do your jobs and to be better techs, right? Instead of being parts changers. So we're going to do one on continuity, which today we'll do another one on voltage, and then we'll do another one on amps. Okay, and your meter can tell you all of those things. So this is just as important, I believe, as your screwdrivers and wrenches and all those things. I can't tell you how many times you guys have called me and you have an electrical problem, and I say, okay, go get your meter and put your leads here and here. What do you got? And you say, I got to go out to the truck and get it. And I totally understand it. If you're not familiar with it, you're not going to use it. So I think you'll feel better about yourself if you're more confident on how to use it, right? So what is continuity? Continuity is basically a continuous loop, one complete circuit, no breaks from start to finish or all the way through. There's no breaks in it, okay? And all this does, so if you put this on ohms up here, right there, can you see that right there? That's your continuity section of this meter. Okay, so right now it's not beeping. There's no continuity. So picture this wire right here, right? So right now it's just like that meter. Here's your black lead. Here's your red lead. They're not touching. So if I was to touch them, if I was to put that together, and if I was to take these two copper wires and I was to put these together, crimp them together, you would have a continuous loop, right? One continuous circuit. So let's do that. So let's take this meter and let's touch these leads together. I just duplicated that white wire. It's just one circuit. So how can we use that to test our parts? So instead of just hoping that the switch is good or bad, we can find out. Now, one of the most important things to remember is you never want to test continuity with the power on. No voltage. No, you don't want it on. Kill the power, isolate it, lock out, tag out, all that jazz. Most cases, you can just turn the switch off in the back, okay? You're going to kill the power to the machine. Do it the safest way, just like we're supposed to do it. If it requires locking out, tagging out, that's what you do. Okay, so sometimes the best way to do it is to have the part in front of you, isolated by itself. But a lot of times you can do the work right on the machine, but you would just have to disconnect any other connections, like on the back of a timer. Let me turn my camera around here. On the back of a timer, you're going to see all these switches here. And usually there's a lot of red wires that go in from one to out to the other, right? And that's our common tab, right? You'll see all these red wires and a whole bunch of wires connected. So if you were to let me show you how continuity works with this table. Let's pretend this is the dish table right here, right? So dish tables, it's conductive. The whole thing is conductive, but wood's not conductive. So whenever you're doing continuity tests, you want to make sure you're isolating it from any other interference that might be affecting it. So, if you're going to test this micro switch, and we'll get into that later, you want to make sure you isolate it, whatever's possible, okay? And that would mean pulling off the wires. So take a pair of needle nose pliers, pull them off, just isolate it from anything else that you're checking, and I'll show you how to check that now. But let's start with a basic switch first. So I took a little grinder and I cut this out just so a lot of times it's easier to understand how things work if you can see what's going on inside there. So this is a basic prime switch, right? It's as basic as a switch on the dish machine as we have. You've got an in and you've got an out. So you've got that beginning of the wire and the end of the wire. So it goes in and comes out, right? So as you can see inside, there's some contact points right there. Okay, and when I activate it, I make contact. See how that works? I make contact, and I'm basically doing this, putting them together, right? That's what I just did. I'm just making that loop. You're making a continuous circuit, a continuous loop for a current to flow through, right? Now, I'm going to be jumping back and forth a couple times because it's easier, but I have these alligator clips so I can use. If the machine is holding the part for you, then you don't need these, but for demonstration purposes, I'm going to be going back and forth quite a bit. So let's say, now when it comes to checking continuity, you don't have to worry about which wire goes where. We're just connecting the wires together. That's all we're doing. Doesn't matter black or red or black, whatever. Okay, so I just connected them together. I got my amp meter, my voltmeter on ohms here. Now remember that beep? It should beep when I put these together. As long as you got a good connection. Pardon me here. So, see that? Contacts come together, it beeps. And we're just checking the functionality of the switch. So in this case, this switch is absolutely fine. It doesn't have a crunchy feel to it. It springs back nice. I got continuity when it's on. I don't have continuity when it's off. So this switch would be fine. There's be no sense in replacing this switch at all. Okay. Here's another switch. This is another basic switch. And this switch is a master switch for the dish machine, right? So it's got an on, it's got an off. It's got 4 tabs. So in this particular case, you'd have a black wire here and a white wire in either direction. I'm not sure which way it would be, right? But you want a black wire on this side and a black wire on that side, and white to white on this side. You don't want to have black and white to black. Now I'll show you why. Because it just runs from one side through this copper strip here to that copper strip, right? One side to the other. We're checking from one side of the switch to the other. And when you activate the switch, it pulls them apart. See that copper strip right there? And now it's disconnected from the other side of it right there. So when you put it together, again, now it bridged those together. It made them together. So you have one continuous loop, right? So it's either on or off. So let's check our continuity between those two. So if you want to see if the switch is bad, and you can do this right on the dish machine, you don't have to take it off. I would pull the wires off of here on both sides, and then put your contact leads on here and activate it. So it's made a connection. Now I broke that connection, and you could do it on both sides. Do it on both sides of that switch. Let's go down here and do it to those. The switch is fine, right? So basically you're just making sure that the contact points are working, right? So this one has good contacts. It's not all crunchy. It's working good. There's no reason to replace the switch, right? I know some of you guys are just saying, I put a new master switch on because I wasn't sure. Well, you didn't have to do that. If you did this simple test, you'd know it wasn't this, okay? Let's get into something a little bit more complicated. So these switches on the timer, this is a multi-purpose switch. It's a dual-purpose switch. You'll see 3 terminals on these switches, and that does not mean that it's a 3-phase switch. A lot of our bigger dish machines will have 3-phase power. You'll see 3 wires going to a part. These are all 110-volt switches, but this is just a dual-purpose switch. And you'll see right here, it says NC and NO, and that means normally closed and normally open. It doesn't mean no. No, it's normally open, normally closed, and this one down here is your common, right? So all that means is it can either work, it could either be on right now with this switch on the off position, as we would think, or on here. So it could either be activating something or turning something off. Sometimes it turns it on when it's like that. It just depends on what you want the switch to do. So for example, if you look at this timer right here, it's in the down position on the master side. So when the timer does its thing and the timer's all done and it rests in that little slot right there, it turns it off, right? So that little leg is in the off position. But the next thing, we started again, and the second one over is the detergent cam. You see how it went down? Well, when this one's down, it's off, and when this one's down, it's on. So that's what this does. So we want to send power through the switch when that lever is down. So how do we test this switch? Same thing. We'll put one side on the common, doesn't matter which, and then we'll put another side on here. Now obviously I've connected to the side that says normally open right there, NO. So that means when it's in the open section, I'm not getting any continuity. But when I activate it, I get continuity. It's making that loop now through here, right there. And when I break it, now I don't. So the switch is working in that position. So if I was to put this contact here, it should beep right away. Sorry guys. See how it's beeping right away? And now it'll do the opposite. So when I activate the switch, it turns it off. So if you're not sure, as a matter of fact, I would recommend testing both sides of the switch. So when you're doing continuity tests, check both sides. Make sure it's on or off when it does either or, okay? And to be honest with you, 95% of the time, 97% of the time, if you hear that click, most of these micro switches are fine. But it's always a good practice to test them because you just never know, okay? But I wouldn't replace the switch because it ohms out, it clicks, it's fine. Don't just replace it because you aren't sure. You can be sure. I'm completely sure this switch is fine, right? Let's do another kind of switch. Let's do this one here. So this is a start switch. Again, it's got the normally open and normally closed tabs, right? So the switch will do, they make these switches to do all kinds of different things for different machines, okay? But on a dish machine, right, when we go up to it, to activate the machine, we hit it to start, right? And we let go of it, and it does what it does. We can test it the same way. We will put a lead here, and we'll put a lead here, and then activate it. It works. When we put it here, it should beep right away, right? Because I'm not activating it. So it's activating. Now when I turn it, when I push it on, it should turn it off, right? Which it does. So this, by ohming out the switch or doing a continuity test on this switch, I know that it's fine. I got that click I'm looking for. It's activating in both configurations, right? It does what I want it to do. All right, let's move over to the switch here. This is a float switch, and all the conveyors that we have, the CMAs, the ADS, they all have float switches in them, different types. This one is for a bar machine, the ETAF, right? And this is a float switch that activates, it tells the machine that it's okay to turn the heater on. So if you wanted to see if, it's like my heater's not coming on, why won't the heater come on my machine? You could, this is where you're going to start right here, right? So the heater won't turn on unless this says it's okay to do so. So let's go ahead and you'll see it's got two wires to it, and it goes up inside here, comes back out. Just makes that loop that we're talking about. And this is a magnetic type switch. So when it goes up, there's a little reed switch in there probably that goes to the side. So it's either going to be touching it or not touching it once this magnet goes up there. So I'll show you how that works real quick. Let's connect one side of the wires to here. And just to keep reiterating, you don't want any voltage on them. Turn the power off. So as this is sitting inside the tank of the machine, the water's drained out. We're still on ohms. So the water's drained out of the machine now. As it's filling, once it gets to the top, it says, okay, you can go ahead and turn the heater on. Drain the machine, don't turn the heater on. You never want to have a heater on when the machine's empty. Okay, so this is working absolutely fine. No sense in replacing the switch at all, just by doing a continuity test. Okay. All of those conveyors are going to have them. If it's got a tank in it, it's going to have a float switch, so you should learn how to do that. Let's go to a door switch. So every machine that we use out there, where is my other one? All those machines that we have out there have door switches, right? Safety switch, door safety switch. This one is from a CMA, but it does the same exact thing. So if this is mounted to the machine, there's a little tab, usually like a little metal arm that sits right here. You open the door and it lets this off. When you close the door, it closes it, right? I know a lot of you guys have changed door switches. You've told me so. I've changed a door switch and that's not what it was. Well, you didn't have to change the door switch if you did this simple test. On an ADS machine, I think you got to take 4 screws off, but you'll to access this panel just like this. You'll see the 2 wires connected usually right here at the top. Power's off, remember? So when that door switch is open, you can touch your wires here and then hit the activate it and see if it turns on and off. If you get that beep, you know your door switch is fine. There's no sense replacing this door switch. Okay, and it's got contact points. All these switches have contact points, like I said. Can you see them in there? So, piece of cake. So these door switches are real simple too. No sense replacing it if you got continuity from one side or the other, and you got that nice click, nice strong click. All right, let's move to this. So, can you do continuity tests on a contactor? What do you think? How would we even start? What are you looking for here? Well, I would highly recommend that you do not do continuity tests on contactors or anything with a coil. This has a coil. Drain solenoids have a coil. Water solenoid coils are a coil, hence the word coil. So there's a couple things you can test kind of, sort of, and I'll show you if you want to here. So I took the cover off the top of this, and you'll see those contact points right in there. Right there. And how a contactor works is, remember that timer? So that timer, that first master switch, the timer, when that's on, it sends power to this coil here to turn the motor on. This is for the wash pump, right, on the dish machine. So it sends power to this coil. A white wire here and a black wire here, or vice versa, right? And there's one wire right there that goes and it gets wrapped around this bobbin of 100 times or 1,000 times or whatever the requirement is, and it comes out the other side. And when you apply voltage to it, so it can go through it, so voltage goes through something, right? So it's just going through it. It's going in one side, wrapping around that 1,000,000 times and coming out the other side. And it creates a magnetic pull, and it pulls down these contacts. So remember how we were physically doing that? Well, that's what the coil does. All that coil does is pulls it down for you and makes contact there, just like that, right? And it makes contact. So you can kind of do a voltage or a continuity test. I don't recommend this being 100% accurate because this could be weak. The coil could be not working so great and not pulling this down all the way, but you can kind of see, look at. So I'm doing what the coil is supposed to do by doing it manually, and I do have continuity through here, right? But the best way to check a part that's got a coil on it is with voltage, okay? And we'll cover that in the next segment, but remember when I first started this thing, I said, well, can you, there's other terms like resistance. So you see on the meter it says 420. When I check this coil, when I test the coil here, I got 420 ohms of resistance on this coil. And you could, a lot of these ratings, this one doesn't say, it says 50 ohms of resistance, probably when it's got power to it. So when you apply power to it, you probably have 50 ohms of resistance, and then you can check that way. But for continuity sex, remember we're talking about continuity, it's not beeping, right? So it's giving me, because there's a pole piece that goes down through the center, I guess I'm not getting a beep there, right? Not getting that beep I'm looking for, even though it's one wire from one side to the other. So, and as you can tell on this is one piece of metal going from one end to the other, so you can't, it gives me contact, but it's kind of like doing that, right? It's one solid piece. So, again, with contactors, anything with a coil, I would check it with voltage instead, right? So, let's see here. Here's, like I said, this is another coil type piece of equipment. So you got one wire going in here, wrapping around a million times and coming out here. So in this particular coil, I'm getting it ohms, but it's because it has a metal case. Remember, there's metal all over this place. Do I have this effect here going on with this? Maybe. So the best thing to do with this, with any type of the coil, is apply voltage. And it's either going to, when you apply voltage to this, it's going to suck it up magnetically and release when you take the power off of it. So don't do continuity tests on coils, okay? Unless you know exactly what the resistance levels are supposed to be. But typically we don't need to worry about any of that. So anyways, hopefully that answers and helps you guys understand what continuity means and how to use it to your advantage, okay? Use your meters, guys. Use your meters to check your parts instead of throwing them out, all right? Thank you.